morning, ladies and gentlemen. As Sergio said, I'm currently working with Czech Technical University, but before I was working at the Erasmus Medical Center, where we started a project in development of universal hyperthermia treatment planning tool, and I would like to show you the results of our study. Just to summarize in one slide, I wanted to show you the treatment planning overview, how we do it for the Hypercolor 3D applicator. So we start with the CT scan, which we delineate using automatic segmentation routine in about 30 minutes of computer time, which is after the segmentation is afterward checked by medical personnel, which takes also about 20 to 30 minutes. Then we import this model into simulator, 3D simulator, which is, in our case, Sim4Life, together with the applicator. Here you can see the Hypercolor 3D with 20 patch antennas. We combine the applicator with the patient model according to the required positioning. We run 20 harmonic electromagnetic field simulation on 434 megahertz, and then we combine the feeding signals of individual antennas in order to obtain highest specific absorption rate in the target region, which you can see here. For this, we use our in-house developed tool, Video. Here you see CTV, which is, we use the same target as for the radiotherapy. So in this slide, it's overview how we are doing treatment planning for the head and neck and also for deep. So for the deep system, we use Sigma 60 and Sigma I. At the beginning, we have to decide which applicator we are going to use. If the patient fits into Sigma I, we use Sigma I. Then we do a specific CT scan in which Sigma 60 patients, the legs are supported during the CT scan, so there is a different leg position for both applicators. Then we do a segmentation and treatment planning in the Hyperplan. And we import these results into our in-house developed tool for optimization, which we call Video. And then from that, we get the amplitude and phases of the feed-in signals. Here you see the routine I described you for the Hypercolor 3D. For the treatment planning, we use the different software than for deep. So our goal in this study was to unite all our treatment planning into one routine. And for that, we use Sim4Life, which is a new generation of the simulation software from the same company as Semcadix. In the first step, we implemented all available applicator models. We use manual measurements for the dimensions or available literature. So on this picture, you see a Sigma 60 model. Here, a Sigma ellipse. We also implemented Sigma I. So these two we have at Rotterdam. Here you see the model of the Hypercolor 3D. And we also implemented the Alba 4D and IMC8 to just demonstrate the universality of the tool. All applicators are fully parameterized, so if you want to change dimensions, you can easily do it by changing the parameter file. To allow easy use in the clinic, we developed a following tool interface. At the beginning, these values are predefined as the patient directory, Sim4Life path. Here you can specify the patient number and, for example, a CT number. Here you can select the applicator, so you see it's the same common interface for all applicators. So if we are performing the Hypercolor 3D, we choose here Hypercolor 3D. The frequency is automatically filled. We use 434 megahertz. If you want to use Sigma I treatment planning, we select Sigma I. For Sigma I, we use 100 megahertz. Am I right here? 100 megahertz, yeah. For Sigma 60, we use 77. Those are predefined frequencies, but if you change those frequencies, you can fill any frequency you want in this field, and then the tool will automatically account for this frequency in assignment of the dielectric properties. So as an input into this tool goes the applicator information. You select the applicator, type, frequency, and the segmentation files, which contains a tissue segmentation. Then the outer surface segmentation, which is used for automatic positioning, which I will show you on the next slide, and also the target delineation. So on this slide is shown how the tool looks for the sigma I model. I forgot to tell that on this picture there is a red light here, which will not let you perform the hyperthermia treatment planning. So it has to be green. It will become green if all required fields are failed. As I said about the segmentation, the patient delineation, the surface delineation, the target. Here we select sigma I. Here you can also specify certain distances, so which are shown here. Those are our control distances which we can measure during the treatment. And you can also specify the applicator rotation. So the automatic position routine is as follows. The applicator is in this direction, centered to be in the center of the target volume. Then the tool will automatically move up and down the applicator to have equal distance E and B. And then the applicator is rotated in order to have as uniform as possible, as equal as possible distances A and C and E, F and D. So this automatic routine follows the manual routine which is applied at Erasmus. Sorry, what did I do? I don't know what I pressed. This? Yeah, okay. So if we apply this automatic positioning routine, it will save 10 to 20 minutes of the operator time. And here I will show you some example. This is a 3D model from Sim4Life. Inside the Sim4Life, there are also all the distances present, and there are also this distance, which is distance from the patient surface to the applicator. And we have requirements that the patient cannot be closer than 4 centimeters from the active antenna. So this distance is also visualized in the 3D model. Here you see a print screen from video with a normalized SAR pattern. And here is a cumulative histogram. Here is a normalized SAR. Here is the volume. This is for the patient, the total patient model. This is for the HT, for the target. And values of TC25, which you obtain by going to 25% of the normalized SAR. You go up, and you will obtain, in this case, 99%. TC50 is for the case 81. As Hannah said, we want to go we want to have a TC25 over 75% following the study of Lee. As a next example, what I did for this patient model is that in Sim4Life, it's possible to change to modify the patient, for example, the leg position. So what we did, we started with the straight position, and then we elevated in with the 5 degrees, I believe, or maybe 2.5, to study the influence of the leg elevation. And also, here you see that the tool also allows you to specify the different water bubble shape, which you can specify, which is by default flat, but you can specify this curve. Here are the results for this patient. So if we did it by 2 degrees, the leg elevation, and as you see, there is no influence on TC25. There is a small drop in TC50 for the elevation from 0 to 10 degree. And the water bubbles extension start to go down for TC50 after 3 centimeters of the water bubbles extension. This is just an example to show you the possibility of the tool we have been developing. To conclude my talk, we successfully developed the universal tool which covers all the treatment planning requirements at Erasmus Medical Center. Automatic positioning, which follows the manual clinical routine, saves 10 to 20 minutes of the operator time. And with joining all our simulation requirements into single routine, we will have easier maintenance, so we don't need to do a QA for 2 different softwares. And with this, I would like to thank you for your attention.
Thank you very much, Thomas. Do you have any question? Yeah.
This seems to be a very interesting approach to have such a treatment system. What about the segmentation tool? Is it an automatic segmentation and manual segmentation as well? Or?
Yeah. So in this moment for the head and neck we have an automatic segmentation routine which is Atlas based, and the manual segmentation is just to verify that the automatic segmentation is correct. Yeah. And for the deep treatment planning, we are currently working on, or people at the Rotterdam Medical Center are working on also on the automatic segmentation procedure, which will be done in a MIM, which is the radiotherapy segmentation routine.
And is it very time consuming, or is it fast?
The automatic segmentation routine for the head and neck is on standard PC, it's about 20 to 30 minutes. And as output, you have the delineation. So the idea is to save the operator time, and when in head and neck, if you want to do a full segmentation, it will take you 6 to 8 hours, versus 20 to 30 minutes of the operator time. But I believe the MIM software is faster than that.
Yeah, currently we are also using ISEG, and we will be starting to use MIM in the next coming days.
So yeah, the ISEG is the manual segmentation routine, so software. Yeah.
Yeah, with MIM it will be more automatic, and we will reduce the segmentation time.
Yeah. Very nice work, Thomas. I wonder, since you implemented all the different applicators, although even those which are not at Erasmus, do you plan to extend this tool for other users? So that it will be available through Sim4 or something.
So yeah, this is in this moment it's in clinical test at Erasmus Medical Center, but the idea is that once it's verified, let's say that at Erasmus, currently I am cooperating with Dario Rodriguez from Maryland. So I think that will be a next center where we will provide this tool, and in the future we would like to spread it to the clinical sites. But every time only the applicators, my vision is that every time the center has a certain applicator, and it will get the model only for that applicator. So I don't want, let's say, to use this tool for some comparison.
Thank you, Thomas. Do we have any other questions? So I think at this time we are also